Hello student, now coming to the part of monochromator. Okay, so output from a wavelength selector, monochromator is nothing but a filter. Okay, so output from a wavelength selector is a band of wavelength. Okay, so now discuss about monochromator and filter. So there is a certain difference between monochromator and filter. So selection of monochromator selection procedure is diffraction and filter shows absorption. For monochromator wavelength width is narrow but filter wavelength width is wide. Monochromator cost is expensive, filter is cheap, portability is none but filter portability is very okay. Capable of recording spectra, monochromator have capable of recording spectra but filter does not have capable of recording spectra, and both are suitable for quantitative analysis. Okay, so see, filters are very simple. They are sheets of plastics or glass that simply absorb wavelength other than those required for the analysis. Okay, so filters are very simple. They are sheets of plastic or glass that simply absorb wavelengths other than those required for the analysis. Generally, the range of wavelengths allowed by a filter is relatively wide. See the monochromator part. Monochromator are far more complicated and comprise a series of optics inside a light-proof box, which has entry and exit slits, which allows the radiation of all wavelength in and a narrow range of wavelengths out. Okay, so monochromator are far more complicated than filter and comprise a series of optics inside a light-proof box, which has entry and exit slits, which allows the radiation of all wavelengths and a narrow range of wavelength out. Okay, now come to the part of detector. Okay, so an infrared detector is a detector that reacts to infrared radiation. Okay, it is simply a transducer. Detector is basically a transducer of radiant energy. Okay, so infrared detector is a detector that reacts to infrared radiation, and it is simply a transducer. Basically, detector is a transducer of radiant energy. There are that means in IR spectroscopy, two types of detector is used. One type is thermal detector, another type is non-thermal detector. Okay, so there are two types of detector we can use in IR spectroscopy. One type is thermal detector, another type is non-thermal detector. Okay, so first see thermal detector. Thermal detector can be used over a wide range of wavelengths and they operate at room temperature. The disadvantages of thermal detector are it gives slow response time and lower sensitivity relative to other types of detector. Okay. Now see the types of thermal detector. So there are four types of thermal detector. One is bolometer, second one is thermocouple and thermopile, third one is pyroelectric detector, and fourth is Gole cell. Okay, so there are four types of thermal detector. So we will discuss these four type of detectors one by one. Okay, so first see bolometers. Bolometer is derived from a Greek word bolometron. Bolo, that means for something thrown, and metron means measure. Okay, so bolometer is derived from a Greek word bolometron. Bolometer is a type of resistance thermometer constructed from strips of metals such as platinum or nickel, or from semiconductors. Okay, so bolometer is a type of resistance thermometer constructed from strips of metals such as platinum or nickel, or from semiconductors. They show a relatively large change in resistance as a function of temperature. It forms one of the arm of Wheatstone bridge. A similar strip is used as balancing arm, which is not exposed to the falling IR radiation. Okay, so it forms one of the arm of Wheatstone bridge. That means bolometer forms one of the arm of the Wheatstone bridge. A similar strip is used as balancing arm, which is not exposed to the falling IR radiation. If IR radiation fall the bridge then it becomes unbalanced due to change in the resistance occur due to the change in temperature. Okay, so if IR radiation fall the bridge, then it becomes unbalanced due to change in the resistance occurs due to the change in temperature. This causes current to flow, which is measure of intensity of IR radiation. Okay, so in this way bolometer detector works. Okay, now see another type of detector, that is thermocouple. So thermocouple, basically you people have already known what is thermocouple. So thermocouple consists of a pair of junction formed when two ends of metal such as bismuth and antimony are fused to either ends of dissimilar metal wires. Okay, thermocouple consists of a pair of junction formed when two ends of metal such as two dissimilar metal such as bismuth and antimony are fused to either ends of dissimilar metal wires. Heating capacity of absorbing element is small as to detect the change in temperature. Potential varies in the two junction with the difference in temperature. One junction is cold junction, which is reference junction kept at constant temperature, not exposed to IR radiation. Okay, so one junction is cold junction, which is called reference junction, and it kept at constant temperature, not exposed to IR radiation. The other junction is hot junction, exposed to IR radiation, which increases temperature of junction. Okay, so the other junction is hot junction, exposed to IR radiation, which increases temperature of junction. Temperature difference due to falling IR radiation generates the potential difference, which amounts to IR radiation. Okay, so temperature difference due to falling IR radiation. So temperature difference due to falling IR radiation generates the potential difference, which amounts to IR radiation. Hot junction is generally blackened to improve its heat absorbing capacity. Okay, we can use thermopile is also as a detector. Thermopile is basically when two or more number of thermocouple connected. Okay, so then this type of thermocouple is called thermopile. So thermopile detectors are voltage generating device which can be thought of as miniature arrays of thermocouple junction. Okay, when two or more thermocouple are connected, then it called thermopile. Now see pyroelectric detector. Okay, so pyroelectric detector are constructed from single crystalline water of pyroelectric material, which are dielectric materials which have special thermal and electrical properties. Okay, so they are pyroelectric detector are constructed from single crystalline water of pyroelectric material, which are dielectric materials which have special thermal and electrical properties. When an electric field is applied across any dielectric material, electrical polarization takes place. The magnitude of polarization is a function of dielectric constant of that metal. This pyroelectric crystal is sandwiched between two electrodes which are IR transparent. The pyroelectric crystal acts as a temperature dependent capacitor. When IR radiation fall, there is a change in temperature which alters the charge distribution across the crystal, which can be detected as a current in an external circuit connecting to two-sided of capacitor. Okay, so the pyroelectric crystal acts as a temperature dependent capacitor. When IR radiation fall, there is a change in temperature which alters the charge distribution across the crystal, which can be detected as a current in an external circuit connecting to two-sided of capacitor. Magnitude of current is directly proportional to surface area of crystal and rate of change of polarization with temperature. And last thermal detector is Golgi cell. Okay, so they are sensitive gas thermometers. These cells are sensitive to gas thermometers. Xenon gas is contained in a small cylindrical chamber which contains a blackened membrane on one side while other side has a flexible diaphragm. Silvered outside. Okay. A beam of light is reflected from the silvered surface to cathode at a vacuum phototube. When IR radiation fall on the blackened membrane, it is heated, which in turn heats xenon gas by conduction. Okay, so when IR radiation fall on the blackened membrane, it is heated, which in turn heats xenon gas by conduction, resulting in increase in pressure causes distortion of silvered diaphragm. As a result, the fraction of reflected light which strikes the active surface of phototube is changed, leading to change in photocurrent. This is related to the falling IR radiation. Okay, so as a result, the fraction of reflected light which strikes the active surface of phototube is changed, leading to change in photocurrent. This is related to the falling IR radiation. Now come to the part of non-thermal detector. So non-thermal detector basically thin film overlaps over non-conducting surface. Thin film overlaps over non-conducting surface. They absorb of IR radiation. Non-conducting valence electron to higher energy conducting state, and electrical resistance decreases and voltage drop occur. So in this way non-thermal detector works. Okay, so in this way non-thermal detector works. So first is photovoltaic detector. So first, for infrared radiation falls on the photovoltaic detector. Okay, so it generates a small voltage. Detector detects the signal. Okay, so see, they consist of a thin film of semiconductor materials such as lead sulfide, mercury cadmium, telluride, or indium antimonite deposited on non-conducting glass surface and sealed and sealed into an evacuated envelope to protect semiconductor from atmosphere. Okay, so this detector consists of a thin film of semiconductor material such as lead sulfide, mercury cadmium tellurate, or indium antimonite deposited on non-conducting glass surface and sealed into an evacuated envelope to protect semiconductor from atmosphere. Absorption of radiation by these materials promote non-conducting valence electron to a higher energy conducting state, thus decreasing electrical resistance of semiconductor. Okay, so in this way, non-thermal detector like a photovoltaic detector, photoconductive detector work. Okay, so in this lecture, I have discussed about the detail. In this 2 or 3 lecture, I have discussed about the detail of each and every part of IR spectrometer. Okay.